From the beautiful South Studios of Way Happy, this is Mr. Meyer and 3-6 solving systems again, but this time with 3 variables. Guess what? 3 variables means you need 3 equations in order to solve, right? So that's a little scary. All right, here's our rules. Step 1, you see these 3 scary equations. Step 1 is I need you to look at all 3 equations and find out what variable you think would be the easiest to eliminate. So you're going to use one of the equations to knock out the other 2 equations, eliminating one variable. Now, as I look over there, the x's all look pretty hard to eliminate. The y's look pretty difficult. I mean, the first and third could work, but I need to do it twice. So really, I'm noticing that the z's, this equation right here, he could easily knock out the 3 by multiplying it by 3. He could easily knock out the 2 by multiplying it by 2. So I'm feeling pretty good that that's the guy I'm going to want to eliminate in this problem. So that's what I mean by figure out who you want to eliminate. It definitely looks like z's are going to be my easiest choice. Then go ahead and do that. So here we go. I'm step 2 now. I'm going to combine equations 1 and 2 to get rid of z. So I'm going to get rid of z. So in order to get rid of z, I'm going to leave the first equation alone, 5x minus 2y minus 3z equals negative 7. But I'm going to multiply that second equation by 3 in order to get it to get rid of the z's. And that's my goal. So multiplying by 3, I get 6x minus 9y plus 3z equals, multiplying by 3, 30 and 18 was at 48. All right. And if you notice, when I combine, I get 11x minus 11y, that's interesting, equals negative 55. Hey, and just for fun, that's your new equation, right? We're going to need this guy in a minute. We'll call him equation 4. So whatever equation you make, you can call that equation 4 if you'd like, because 4 and 5 are going to be very important. A little heads up right now, I'm noticing about equation 4, they're all divisible by 11, and I would choose to do that. I would actually make this x minus y equals negative 5 just because it's easier. Now, you don't have to, but just if you notice it, go ahead and do it. If you can divide them all by 3 or 4 or something, do it. It makes your life a lot easier. All right, so that's my new equation 4. Now I will go ahead. We've combined 1 and 2. Now I'm going to do 2 and 3. Now, again, I have to do the same variable that I just did. So I have to do z now. There's no ifs, ands, or buts. You have to do this. This is all part of step 2. We have to combine the 2 equations to get rid of a letter. Then we got to combine 2 other equations to get rid of a letter. So I'd have to multiply equation 2 by 2. So that would give me 4x minus 6y plus 2z equals negative 32. And I can copy this guy down, 3x plus 4y minus 2z equals 7. And you can see the z's will cancel now that my elimination is set up nicely. And so I will add straight down and get 7x, and I will get minus 2y equals, what is that, negative 25? And there is my equation number 5, we'll call it. Now, step 2 is done. Step 3 says solve those 2 equations. In other words, look at equations 4 and 5 and solve them. Why? Because they should only have 2 variables. In this case, they do, x and y. And we have 2 equations. We know how to solve 2 equations with 2 variables. You can graph it. You can substitute it. You can complete this, or not complete the square. You can graph it or substitute it or eliminate, again, your choice. So now I will take equation 4 and 5. So step 3 is now do 4 and 5, right? So now I'll do 4 and 5. Let's see, I'm going to leave 5 alone. 7x minus 2y equals negative 25. And I got to work with this equation here to get what? The y's to cancel easily. So I'm going to multiply by negative 2. So negative 2x plus 2y equals 10. And I finally get 5x, the y's cancel, equals negative 15, or x equals negative 3. And I finally got one answer. Hallelujah. Now I can go back anywhere to 4 or 5 and plug it in. So now I will plug into 4 or 5, right? You don't have to use these numbers 1, 2, 3, 4, 5. You don't have to use those all the time. I'm just doing that so you know where I'm going. I'm going to plug it into 4, which was x minus y equals -5. But I know x is -3, so -3 minus y equals -5. That means y must be 2, right? And there is my y. And now we go to step 4, which is, hey, solve for the missing variable. So you can go back anywhere over here, and you can plug in your x and your y that you found. I think I will use, maybe the last equation looks the simplest to me. So that will be, here's step 4. I will say 3 times a -3 is what I found for x, plus 4 times a 2 minus 2z equals 7. So what is that? -9 plus 8 minus 2z equals 7. It's -1 minus 2z equals 7. -2z, let's say I move that 1 over 8. So z must be -4. And now you write your answers as -3, 2, and -4. Beautiful. You have just solved 3 equations with 3 unknowns. You can see it takes a lot more work, but definitely doable. All right, let me set up the next question, the next problem, which is a word problem. See how you like that. So you can see the table shows the number of each type of tickets sold at and the total amounts for that play. Find the price of each ticket. So on Friday, we know we sold 200 orchestra, 30 mezzanine, 40 balcony, and we made that much money. Then we sold 250 orchestra, 60 mezzanine, 50 balcony. We made that much. And then on Sunday, we sold some orchestra and mezzanine. Easy for you to say. And then we sold and we made $1,050. So now we want to figure out how to solve that. So first we got to make the equations. Well, this is luckily we want to know how many orchestra, we want to know how many mezzanine, and we want to know how many balcony. That's going to be my variables, and I can actually set up really easy from this chart. 200 x's plus 30 y's plus 40 z's is equal to 1470. And I have 250 x's plus 60 y's plus 50 z's equals 1950. And 150 x's plus 30 y's equals 1050. And there's your equation, your x, your y's, your z's. Holy macaroni, have some fun. Now, first thing I would probably do is I notice everybody is a multiple of 10. So to be honest, I would probably drop the 0 off of each problem. I would just divide everything you see by 10. Legal, right? Because if you do it to everybody, it's legal. And in this case, I'm going to do it to every single one. There's probably other things I could do to make these numbers a little smaller, but that was just the first thing I noticed as I was writing it down. But now I could go ahead and solve. So again, look at this, by the way. We have a nice equation here that already has an x and a y. I wish I could make one of those other two, combine them to make one that has x and y, and we'd kind of be a step ahead because we already have one that only has 2 variables. So I'd like to eliminate the z's, but some of you might notice it would be easier to eliminate, in this case, I think the y's. The y's look the easiest to eliminate for me. So again, I'm going to drop off a 0 real quick. So I'm going to have 20x plus 3y plus 4z equals 147. I'm going to have 25x plus 6y plus 5z equals 195. And I'm going to have 15x plus 3y equals 105. Now, I think I'm going to combine, step 1, I'm going to get rid of y's. So I'm going to choose to eliminate y's. So I'm going to do, let's call this 1, 2, and 3. I'm going to combine 1 and 2, right? And I'm going to multiply the first one by -2. So -40x minus 6y minus 8z equals, what's that? -294? -294. And this is 25x plus 6y plus 5z equals 195. Looks like I'm about 10 minutes in already. That's crazy. All right, I'll finish this up in a second, and I'll be right back. All right, seamless transition there. And as I combined this down now, it looks like I'm going to have -15x minus 3z equals, that's almost 100 there. So 294 minus 195 is going to be 99, but the negative was bigger, so negative 99. Now, I don't know again if you noticed, but those are all divisible by 3. So here's our new equation 4, but this is going to be, let's divide by negative 3. 5x plus z equals 33. I just divided everybody by negative 3 because I noticed to make a smaller equation. That's my new equation 4. All right, staying on that pattern, I got to get 1 and 3 combined because I think that would be easy. I'm going to do 1 and 3 to make a new equation 5. So 1 was 20x plus 3y plus 4z equals 147. In order to work, I'm going to multiply 3 by negative 1. So we'll get negative 15x minus 3y equals negative 105. And if we add straight down, we get 5x. The y's cancel, but we've now introduced a z, OL, is equal to now 47. The hundreds cancel, so 47 minus 5 is what, 42? So we get 42. Now, 2, 5, nothing goes into both of those, so no luck. So here's my two equations, but look at that. They both have a 5x in them. There's my new equation, 5. So I'm going to use that to my advantage. I'll leave the number 5 alone, so I'll leave this as 5x plus 4z equals 42. And equation 4, I'm going to multiply everybody by a negative. Negative 4x minus z equals negative 33. And now the 5x's cancel. I get 3z equals, what is that, 9? So z is 3. Yes. So I got z is 3. Now I can go back. I can plug it in here and tell you. Plug it in right there. You want to plug it in either 4 or 5. I'm going to plug it in there and get 5x equals 30. Which means x is 6. And then lo and behold, after I got x is 6, then I can plug those guys back into wherever the heck you want to find y. Hey, why not this last one? It looks like it's the easiest. So I will do 15 times 6 plus 3y equals 105. Or what is that? 60 and 30, that's 90. So 3y equals, let's see, take away 90 is 15. So y must be 5. And so there's my answers. 6, 5, and 3, all done. $6 for orchestra, mezzanine is $5, and balcony is just $3. And that's how much we must be charging. All right, long run. Let me ask you a question, and we'll be right back. All right, good effort on that one. And now let's do one more. And look, at this one looks pretty simple. I tried to bring one in that just wouldn't make us cry. So one more time, let's see. Look through the variables. The x's would cancel pretty easily. The y's would cancel very easily. And wow, the z's would cancel immediately. I could take that third equation and get rid of the first equation z and the second equation z really quickly. So guess what? I'm going to do that. I'm going to combine 1 and 3 and get rid of z. And I don't have to do anything except for rewrite it so you see it. But maybe you could already make that new equation without rewriting. So here we go. Equation 4 looks like it's going to be negative 3x plus 3y equals 3. The z's had canceled like we had hoped. And look, we got 3's everywhere. So why not negative x plus y equals 1? That doesn't always happen. It seems to have happened a lot in this video. But it doesn't always happen, but this is great that it does. That's my new equation 4, or whatever you want to call it. Now, that was 1 and 3 combined. So now I'm going to try something like, I don't know why I picked 1 and 3 first. Why not 2 and 3? All right, now I'm going to do 2 and 3. And so 2 is 2x minus y plus z equals 3. And negative 4x plus 2y minus z equals negative 1. And again, trying to get rid of z's, whatever you picked first, you have to do again because otherwise the 4-5 trick won't work. All right, we get negative 2x. We get plus y equals 2. And there's our new equation 5. And now I look at them and I go, wow, that would be pretty easy to make the y's cancel. So I will. I'll multiply this one, the 5. So I'm going to go 2x minus y equals negative 2. Multiplied everybody by a negative 1 there. This guy, 4, I'll leave alone. Negative x plus y equals 1. And now I can add down. I get x equals negative 1. And from there, I'm going to stop. Yes, that's evil. I'm going to stop there and let you figure out what y and z are so I can ask you at the break. Have a great day. Stay happy.